Well, to analyze the circuit as given for the difference or differential amplifier, we will use superposition principle. Got V1, got V2, I'll just redraw it, R1, then we have RF, then we have V2, R2, then we have R3 to ground, RF to V out. So we're going to apply a principle of electrical circuit analysis, especially used when we've got multiple voltage sources or current sources, that is called superposition. So to apply superposition, step 1, and this you must have learned in electrical engineering 1B for the new diploma and in electrical engineering 2 for the old diploma. In step 1, we will assume that we will assume that V2 is shorted, meaning there's no V2, and from V2 we're going to ground directly, which means we've got 0 volt here basically. With V2 being shorted, we have 0 volt there, which means we end up with the following. R1, V1, RF, V out. This is exactly an inverting amplifier configuration. Fire configuration, of which we know the gain in this case will be, which is V out over V1 in this case, will be nothing but minus RF over R1, which makes V out in this case be equal to minus RF over R1 times V1. Okay, we're gonna keep that. Step 2, in step 2 we assume the opposite. We assume now that V1 is shorted, is the one that is shorted. The amplifier configuration becomes minus plus. As V1 gets shorted, that becomes grounded. No, sorry, it's not grounded, let's say. As V1 gets shorted, we get R1, V1 is grounded, then we have RF all the way to V out, and on the positive side where we've got V2, we have R2 going to V2, and we've got R3 to ground. This becomes a non-inverting amplifier configuration for which the input voltage of V at A, which is input voltage here, is nothing but V2 times R3 over R2 plus R3 by voltage divider in that network. As we know, the gain of a non-inverting amplifier is normally 1 plus RF over R1. So that makes no exception. So V out over VA, which is the gain in this case, because VA is the input being applied to the amplifier, will be 1 plus RF over R1. That makes V out be equal to VA times 1 plus RF over R1. And that gives, we know VA by voltage divider to be equal to V2 R3 over R2 plus R3 plus V2 R3 over R2 plus R3, all of it multiplied by RF over R1. 1. Right, Rf over R1, all of it multiplied by Rf over R1. That will be the output voltage. Let me just see something. So if, yes, it is. So if we take if we go with the assumption, but before we go with the assumption, let's just take something as a common factor, which is VA. If we keep VA as a common factor, one moment. Okay, times, yeah, that's okay.